Okay, so protein electrophoresis. And for your monoclonal gammopathies, I always remembered those as you can rock on by yourself. So mono reminds me of like one person, or uno. And so it makes like the little rock sign. And so I always put a note next to that where you can rock on by yourself for monoclonal.
Oh, I never noticed that.
See how it's like the little rocker sign?
Yeah.
And that's going to be your gamma spike. And so what's your normal spike?
A lot lower than that.
Yes, for specifically for gamma. Which one is normally spiked more than the others out of all of them?
Albumin.
Albumin, yep. Normal spike. Albumin. And that's at the positive end. One the book has is Abby albumin is attracted to Andy anode because of his positive attitude. So positive end, which is your anode. Cats are negative. I personally really like cats, but you know, a lot of people feel otherwise. So your cats are negative, and that's your cathode. And then the other one that comes up a lot, or at least I thought with us came up a lot, was cirrhosis. And that one has a beta gamma bridge. And that one I always remembered by the R's kind of reminded me of a bridge. So you have RR together, and so it kind of makes that bridge. It goes like RRH, kind of makes like the little bridge there.
I don't understand.
Sometimes they're stretched. But to me, I was always like, okay, that's the one that has the little bridge in the letters. And that's the one that has the bridge between your beta and gamma.
Oh, okay.
So see, instead of, you know, like here's normal. Normal goes and goes up for albumin, and then has the little, am I on the right one? There we go. And has like the little up and down. Well, for cirrhosis, they just all go together. So one little bridge.
Okay. You just basically associate with things that you're already familiar with.
Yes. Anything that I can think of, like, oh, okay, I can remember it this way. And again, some of them don't work for everybody. Some things that other people remember things by don't work for me. It's just about finding the things that make you remember it, that you can associate with it. So for me, associations are the big thing.
Okay.
And then I'll like write the note next to it, and that way I can remember it. Like, oh, I can't remember, you know, you don't always remember everything, and some of them are like a bit of a stretch, and so I was looking at. page. See, so whenever I have ones like that that are harder for me to remember, I just like write my little notes next to it.
Yeah.
So there's your monoclonal, and then your polyclonal has just like a little less of a spike. Because when you have more people, you have to do a little less work.
What page is that one on? What page is the polyclonal?
Oh, the polyclonal and monoclonal are on 39. And so your monoclonal spike, which is your big rock-on sign, and then their polyclonal is going to be your smaller one in the gamma area. But your albumin stays the same as a spike.
So when it says like which one flows faster to the anode or cathode, like
So your albumin is going to be the one that goes towards the anode fastest, or is attracted. Because I think the one in the book is like anti-anode, or I mean, anti-albumin is attracted to anti-anode because of his positive attitude or something like that. And then I think when it gets in, which one's slow and faster, that's the hemoglobin electrophoresis, isn't it? Because that's what I was thinking of.
I feel like I had a question like that, and I know I got it wrong, and I was like, I don't know.
Oh, we do. Yeah, because they don't talk very much about how fast the protein ones go. Let's see right. Oh, here we go. So their direction is determined by the surface charge protein. Oops. Higher pH Isoelectric. We'll go look that up here in just a minute. Isoelectric. Negatively charged. Okay, so if it has a higher pH, then it's negatively charged. And so if it's on the negative side, it has to go to the positive side. And so it's going to migrate towards the anode, which is a positive. So we need to capture negative for your cathode. And anode is positive. And candy anode has a positive additive. Largest number, albumin has the largest number of free negative charges. So travels furthest with that. So at a pH of 8.6, this is what always got me was the different numbers.
Yes.
So at 8.6, they go albumin, alpha 1, alpha 2, beta, and then gamma. So these go in alphabetical order. I don't know if that helps. So at 8.6, albumin goes first because B becomes before P. So you got albumin, and then you got alpha 1 and then 2. So, and then your beta comes after A, and then gamma after the B. So they go in alphabetical and numeric order. Your options are either cellulose acetate, agarose gel, or starch gel. And I think that cellulose acetate is usually what you hear about, or is usually what the questions revolve around.
Yeah.
I think a good thing to note here is it's supposed to be run on serum. And so if you use plasma instead, it'll result in a fibrinogen peak. So, between gamma and beta. And so what else can cause a peak between your gamma and beta?
Between the gamma and the beta, that's the one with the bridge.
Yep, your bridge. So that could be mistaken for cirrhosis.
So do all of these gels have the same pH?
Do all the what?
The gels, do they have the same pH?
Sorry, one more time. I think my phone went off right when you.
Do all the gels have the same pH or different pHs?
No, they have different pHs. Because there was 8.6 and there was another one too.
It's like 4 point something.
Yeah, let's find that one. Okay, the other ones were hemoglobin electrophoresis. So we can do, let's make sure we get everything from these, and then we'll go to the hemoglobin one.
Okay.
Because those used to confuse me a lot too. I don't know what you're talking about. And reading them in a book is a lot different than trying to like place them out in an easier format. Oh, this could be useful. So your albumin, alpha 1, and alpha 2 are produced by the liver. Oh, sorry. All 4 of them. Albumin, alpha 1, alpha 2, and beta. So all 4 are produced by the liver with the exception of gamma. By the reticuloendothelial system.
I think I had a question like that.
Yeah, so reticuloendothelial system produces gamma globulins. Antibodies are secreted by the plasma cells. I think let me put them over here. So albumins are largest. The smallest molecular weight, but the largest fraction, which means that it's like half of the amount, half of the serum proteins are albumin. So about half serum proteins. It says 52 to 62%. Transport protein and osmotic pressure. So for clinical significance, is usually decreased amounts instead of increased. So like your liver impairment and edema and malabsorption, nephrotic syndrome, burns, they're all going to be shown by a decreased amount of albumin. So if you see an increased amount of albumin, higher than the albumin spike, then it's usually clinically insignificant. Then I know they talk about alpha-1 antitrypsin a lot.
Yeah.
Remember any of those questions?
I don't remember them off the top of my head, but I do.
But have you seen them? Sorry, I said that wrong. Have you seen any of those questions?
Yes.
So acute phase reactions and pregnancy.
And I know I've had questions about acute phase reactors.
Yeah, those come up a lot. And I don't remember. I'm sure we totally did, but I don't remember like focusing on them in school a whole lot.
Yeah.
Another one, alpha-1 is your AFP. You remember what that is?
Alpha-fetoprotein?
Yep, your alpha-fetoprotein. Neonatal, sex, and cancer marker. And our alpha-2 haptoglobin. You remember that what that is?
Haptoglobin, transport. Trying to remember what it is.
It binds a kind of hemoglobin. Do you remember what kind?
No, I don't. Not unless I see it.
Yeah, I think I'm going to do that. It binds free hemoglobin.
It binds what?
Binds free hemoglobin. So, like, if you have hemolysis and that hemoglobin is, floating around, remember you can get like iron overload or damage to your organs. Haptoglobin goes and binds the free hemoglobin to prevent that damage. And it also recycles the usable products. So instead of just eliminating them from your body, the haptoglobin can go and make them reusable, recycled.
So it breaks them down into recyclable parts?
Well, it takes them, and I'm not sure if it does it itself, but it does. It prevents. It does definitely binds it so it can't hurt the tissues and stuff around. But it takes the where are parts of hemoglobin? I can't think of the name right now. It's a longer word. There's some parts of hemoglobin that can't be recycled, and there's some that can. There we go. The protoporphyrins.
There you go.
So it takes out the iron and the protoporphyrin rings. And so anytime you have hemolysis, that haptoglobin is going to be decreased. And then your other alpha 2 is ceruloplasmin. You remember what that does?
Copper. Copper, right?
Yes. Yes, sorry, I couldn't hear you. Yep, transports copper. And your beta are carrier proteins for iron and lipids. So what's your carrier protein for iron? Your transport protein?
Oh, transferrin.
Transferrin. And how about, and then for your lipids is lipoproteins. And then we got gamma. And so all 4 of these, your albumin, alpha 1, alpha 2, and beta, are all produced by the liver. So your gamma is going to be increased in chronic inflammation. And what else? Where else do you see a gamma increase?
Cirrhosis.
In cirrhosis. Where do you see a major increase?
What do you mean?
Where's your big gamma spike? In your little rock-on sign?
Oh, yeah. That one is the... That one is the mono.
Yep.
Mono.
Monoclonal gammopathies.
That's a really good way to remember that.
I like it. That one, I think, is one of my better ones. Some of them are, I'll even admit, are like a major stretch. And I'm like, what was I thinking? Like, sometimes I look back now and I'm like, that doesn't make sense. But hey, if it helped me remember it then.
Yeah.
Okay, so I think we need